Let's try the calculator. 10 plus 15 times 2 equals to 50 divided by 5 equals to 10. Then 78 plus 22 is equals to 100. And let's try 8 squared. The square root is 8. 1 over x is 0.125. Then let's try the percent. 1080 times 12% is equal to 159.6. Another is 150 plus 15% is equals to 172. 200 minus 20% equals to 160. And we have also the delete or backspace and the C function. For example, we have 15 plus. Okay, the first entry is 15. Then I'm going to click 50, but I'm going to click the clear button. Okay, so we still have 15. And let's try 10, and we should have 25. Okay, so that is correct. And there's also the positive and negative function, like for example, negative 10 times 2 is equal to negative 20 plus 5 equal to negative 15 plus negative 30 equal to negative 45 divided by 9. So we have negative 5. Welcome to another C# Windows Forms application programming tutorial. In this video, I'm going to show you how to create a standard calculator that can perform basic arithmetic operations such as addition, subtraction, multiplication, and division. But before we start with the tutorial, if you're new here, please consider subscribing, like and share this video, and click the notification bell so you'll get notified every time I upload a tutorial. I already created the interface of the standard calculator. I use label to display the input and the result of the computation. And for the digits 0 to 9, I use buttons. And also for the arithmetic operators and some other functions of the standard calculator. Okay, so let's start writing codes. Right click anywhere in the form, then click View Code, or you can use the keyboard shortcut F7 to open the code editor. So first thing that I'm going to do here is to create an event for buttons 0 to 9, private void. I'm just going to call it number button underscore click, and just copy and paste these parameters. Then create an instance of the button btn by casting the sender object into a button type. So every time this number button is clicked, it will check if the text of the LBL display is equal to 0. If it is true, then the text will be replaced with the text of the btn. If it is false, then LBL display the text will be concatenated with the text of the button btn that text. Then copy this number button underscore click and select a button and click this events icon in the properties window and look for the click event of the button, then paste the number button underscore click. Okay, so let's try if it is working. Click the start, then click number 1. So we have 1, another 1, another 1. The other buttons are not working yet. So do this to all other buttons used for the digits. So paste. Okay. and also for the 0. So let's try again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Okay, so our buttons for the digits are now working. Sometimes the numbers are in decimal form, so this button will be used to add decimal point into LBL display. So I rename this button into BTN period. Double click on the button. Then I'm just going to copy and paste this line of code and replace this btn.text with just a period inside double quote. Let's try to run the program again. Then, for example, we have 10.5. So it is working. But if we're going to click again this button, it will add more point into the number, which is not proper. To prevent that from happening, we're going to set a condition here. If LBL display that text that contains period, then negate the result of this condition by using logical not. So if it is true, then we are going to make it false and copy and paste this code inside the body of this condition. Okay, so let's try again. 50.333, then click the period again, so it will not add another point because it already contains decimal point. So it is working properly. Next, if an operator button is clicked, the text of LBL display will be stored into a variable, and when number button is clicked again, the text of LBL display will be replaced by the text of the button, and that would be the second input. So open the code editor again, declare variables for the inputs, double. I'm just going to name the variable for the first input as num1 and double num2 for the second input, double result, and string for the operator. I'm just going to name it OP with an empty string. Then another variable of Boolean type to determine if an operator button is clicked. So I'm just going to name it OP flag, then set that into false. Okay, although we can use this OP, but there's reason why I use another variable to determine if an operator button is clicked. Then next is create click event for the operator, private void, and the name of the method is operator underscore click with the same parameters, and create an instance of a button by casting sender to button. Then store the text of the button into the variable op within the text, and set the op flag value into true. Then copy this operator underscore click and select the button, click the event icon, and in the click event, paste the operator underscore click. Same also with this button for the multiplication, subtraction, and also for addition. So when you double click this button, it will open the operator underscore click. Okay. I'm going to display the value of the OP by using message box that show OP, and run the program, division, multiplication, subtraction, and also for addition. So I can now remove this message box. The program should be able to determine if an operator button is clicked, and we can do that inside number button underscore click. So this condition here will just check if the text of LBL display is equal to 0, and if it is true, then this statement will be executed, which means that the text of the LBL display will be replaced by the text of the BTN. So using the OP flag, we can tell the program that an operator button have been clicked. The condition would be or OP flag equals to true. The logical operator is used here, which means that either these conditions is evaluated to true, then this statement will be executed. So let's try to run the program. So for example, we have 100 times. So when I click again, another number, since I click the operator, the text here should be replaced by whatever number I'm going to click. For example, 5. Okay, that is correct. And I'm going to try to click again. So that, for example, 6. So the text here should be 56. And we have only 6, and that is not correct. Okay, so and statement should be written here to set the value of the flag into false again. Okay, so let's try to run the program again. For example, 25 and times 30. So I should be able to enter 30 on the LPL display. So 30. Okay, so it is working now for the second input. But before replacing the first input value in the LPL display with the second input, it should be stored into a variable first. So let's try to check if we are able to get the first input value and the second input value. So I'm just going to use this equal button here to display using the message box the value of the first num, that to string. I'm just going to concatenate it with space, and the value of the second or num2. So I forgot the that show. So for example, we have 45 plus 20. Okay, then click the equal button. So we have here 0, 0. So we are not able to get the first input and the second input. So to do that, when we click the operator, so we have to store first the first input value into the variable num1. So convert that to double, since this variable is of type double, and the value that will be coming from the LBL display is a text, so we have to convert that into double. LBL display that text. Oops. And let's try again. So 10 plus 5 equals 2. So we have only 10, which is the first input value. So we have to store the second value, and we can do that here in the equal button. So num2 is equal to, I'm just going to copy and paste this code. Okay, and let's try to run again. 15 minus 10 equal to, so we have the first value and the second value. And also let's try to display the operator. Okay, plus op plus space, then start the program again. 78, for example, divided by 3, then equals to, so we have 78 divided by 3. So we are able to get the first input, the operator, and the second input value. Now that we're able to get the first and second input value and also the arithmetic operator, next step is to create the computation. So I'm just going to remove this message box, then create a method private void compute. Using switch statement, the calculator will perform arithmetic computation based on the operator. switch OP, then case. So since we have four arithmetic operators, we are going to create four cases. Okay. First is we have addition or the plus sign. Then using the result that was already declared equals to num1 plus num2. Then display the result and LBL display that text equals to result that text. Then call this method inside the btn equal underscore click. Then try the program. For example, 7 plus 8 equals to 15. Try again. 10 plus 30, that is 40. Okay, so I'm going to add codes inside the clear button. So num1 equals to 0, num1, num2 is equal to 0, result equals to 0. Then OP, empty the OP and set the OP flag to false. Okay, then set the text of the LBL display into 0. 9 plus 1 equals to 10, then click the clear button. 5 plus 6 is 11. 12 plus 17 is 29. So it is now working with the addition. Okay, then create another case for the subtraction. So I'm going to copy and paste these lines of codes, then change the condition to minus and also the operator here. And let's try again. 15 minus 3 is equals to 12. Okay, then for example, let's try plus 5, 17. Okay, then another is minus 10 is equals to 7. Okay, so it works with the addition and subtraction operation. Then another case for the multiplication. And oops, not asterisk. So it is x, then this one is the asterisk. Then try 8 times 9 equals to 72 times 3, 216 plus 24 equals to 240 minus 100 equals to 140. And for the last case, for the division, so I'm going to copy the text of this button, click on the properties, then copy this text and paste that inside the double quote and change the operator into division. Okay, then run the program. So for example, we have 45 divided by 9 is equal to 5. Okay, times 5 is 25 plus 25 is 50. Let's try to divide again by 10 is equal to 5. Then let's try to divide by 2 equals to 2.5. Then plus, for example, 14, then 16.5 minus 8 is 8.5. Okay, so the calculator is now able to perform four arithmetic operations: addition, subtraction, multiplication, and division. The calculator should be able to perform continuous computation when an operator and number is clicked continuously. Like for example, if I'm going to click 1 plus 2 plus 3 plus 4 plus 5, then click the equal button, it should return 15. But now it's just returned 9. So to do that, we're going to set a condition here. If OP not equal to empty string, it means that an operator have been clicked already, then we're going to get the value of the LBL display and store that in num2. Then call the compute method. Let's try again. Click to start, then for example 1 plus 2 plus 3 plus 4 plus 5, then when I click the equal button, it gives us 15. Let's try again. 10 plus 5 times 2 minus 15 divided by 3 equals to 5. So now the calculator is capable of doing continuous computation. Another is when the equal button is clicked and the number button is clicked again. That number, for example 5, will be displayed in the LBL display. And that would be the first input value for the next computation. For example, I'm going to click 2 plus 3 plus 5 plus 6, then click the equal button. So we have 16. Then I'm going to click another number, for example 9. So 9 will replace the current text of the LBL display. Okay, so here the current text of the LBL display have been just concatenated with 9. So our program should be able to determine if the equal button have been clicked, and there are different ways on how to do that, but I'm just going to use another variable of type boolean, and I'm going to name it EQ flag, then set that to false, and inside the equal button, EQ flag will be set to true. And another condition will be added here inside the number button. So we have or EQ flag equals to true. Okay, so either of these three conditions is evaluated to true, then this lines of code will be executed. So the first condition will just evaluate if the text of the LBL display is equal to 0, and the second condition will determine if the operator has been clicked by using the value of the OP flag. And this condition, when evaluated to true, means that the equal button have been clicked. And EQ flag should be set to false again. Okay, let's try the program. Then 2 plus 3 plus 6 plus 9 equals to, we have 20. Then click another number. So 9, okay, so that is correct. Then 6, for example, so we have 96. Then if I'm going to click an operator, it should not perform a computation. Okay, so let me try. Okay, so it will perform a computation, and the reason for that is the OP variable, which is used to determine if um, an operator is clicked or used for storing the operator that has been clicked, still contains a value. So when we click the equal button, it is not um, set to empty string. So what we need to do is to assign an empty string into OP, and we can do that inside the equal button, or we can do that inside the our method compute. So OP equals to empty string. So try the program again. So 8 plus 9 plus 5. So we have 22, then I'm going to click 65, okay. Then I'm going to click multiplication times, so it did not perform a multiplication process. Then times 2 plus, okay, so it is correct. Then plus, for example, 10, then click the equal button, okay. Then let's divide the number by 7. Okay, so we have 20. So I think our calculator is now working properly.